Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
How many people were in the F# tutorial yesterday? Yeah, yesterday. Yeah, how many weren't actually? So we have a good number who weren't. That's good. I'm not going to repeat a general introduction to F#. But thank you for coming along to this track. We have where I think it's looking at Wolfram's talk was amazing. I mean the Touch Studio work just looks absolutely fantastic. On the cloud data and devices, I think not all talks are addressing all of those elements, or very different aspects of these elements. We have Manuel, who'll be on the next session, will be looking at the diffuse web of the programming devices in the context of web programming in a very different way. My work is focusing on a very different kind of problem, which is about addressing this issue about whether programming. I am going to take this off. I can't do this. Can we turn this down? This is too loud. Yeah, it's too loud. Too loud. Can you turn it down? It's too loud. Okay, that's better. Thanks. Okay, so this is a curious kind of work. It's work that started with a simple. Sorry, this is a bit distracting. The work that started with looking at how to integrate F# with Excel, actually. We have F# sitting alongside an information-rich environment, which is Excel, and we want the two to work together. Just in a sense, it's a form of hosting. You want to host a programming language alongside a data source, an application. And then we started to look at the applications or the mechanisms we were starting to build into F#. And then we started to think about, well, what are all the other information-rich contexts that people work in? We know database programming is an information-rich context. And we know that there are many kinds of other application sources. But then we started to look at applications of this to web-based data sources. And then, in a sense, we started to think that life today is as a programmer, is very much hosted. We live in a hosted world, right, where we're hosting our programs against the internet, against the web-based data sources. And then when you look at information-rich programming in, say, an enterprise context, then people in the enterprise today are hosting not just against one database, as they might have been 10 years ago, but they're hosting against a whole information context, an enormously large information context, which they need to access through their programming environment. So we need to change. The fundamental principle of what we're looking at here is that we need to very much change our notion of programming language architecture to take into account that the world, that every single programming language context that we work in is information rich in a kind of way that we haven't had to experience before in a foundational level in terms of programming language and compiler and tool architecture and design. So the world is information rich, and all our programs are hosted against information contexts. And that means modern applications are information rich, as you can see that from Wolfram's sort of talk. But our languages and our libraries are very information sparse. And I think the fundamental thing I want to get across in this talk is that our languages need to include the mechanisms to allow the projection of very large and very sophisticated data sources into the programming language context. And I want to, and if we don't have that, then we have a problem. We have a loss of programmer productivity through that. And so what we're doing in F# is putting in one particular manifestation of a mechanism to allow components to project in information sources into the programming language context. And from a research perspective, this opens up, it feels like it's just the start of a discussion about how programming languages should interact with the semantic web, how programming with ontologies, how programming languages should be changed to, instead of being, so much of our modern programming language design is all about how do we tame in-memory objects, how do we program with those objects we allocate on in the memory, and we work with those. But what we're seeing is a shift towards the programming language design has to be thought of as a way of processing information from external sources. If you look from LINQ, in particular in C# 3.0, and you see, well, what was the shift that occurred there? That means suddenly a mainstream language had at its core a mechanism about processing information and sending queries and everything else. And it feels like we're just on that as our languages develop, as our Haskells, as our Scalas, our F# and these general purpose languages develop, they have to become information-rich programming languages. So sometimes this can seem kind of magical. It's not that magical, in fact. It's a fairly simple mechanism we're adding to F# 3.0 called F# type providers. As I said, I think from the research perspective, it's only the start of a discussion. And I'd like to touch on those themes more towards the end. And from the F# perspective, we see these two very complementary technologies you'll see. One is type providers for bringing in the names of all the data sources and services in an information context, and LINQ, which is a way of sending the queries back to those data sources. And LINQ is also a way of publishing and packaging on new data sources and publishing them through various protocols. Together, I kind of think of what we're trying to do here as making a language-integrated data and services. So I use this example in my tutorial. I'll use it again because it's a pretty good one. I should say the web connection here was slow the other day, much slower than I had hoped, but I'm hoping we'll be okay. So let's take a look at what I mean. So in this setting, we've referenced a very small set of you can think of them as libraries, but they're not the first one in particular is not a library as we know it. The others are just some scripting libraries I'm going to be using along the way. And what we've done here is reference one small component which embeds F# against an information source which is enormous, which actually this information source in many ways, if you see its projection into the future in particular, but it's already a very, very large ontology of information with excellent metadata information, that this is in some close approximation, a first approximation to all of human knowledge in the Wikipedia sense of human knowledge. What we've got here is pretty much for every page in Wikipedia, there's a corresponding entry in this ontology in an organized form, which will develop over time. I'm not sure amusement parks needs to have a top-level domain entry for the various domains of information that are being projected into the programming language context here. But the idea that I want to get across is that imagine if you were sitting down in your general purpose programming language and you needed to get this information. Okay, so you, for some reason, and the example I tend to use is the chemical elements, but we could be looking at all sorts of other things, like you want to know the list of books in the world. I mean, the full list of books in the world. Okay, if you want to know if you want to know, if you're an astronomer, and you want to know every asteroid in the world, you want to be working live against the full set of the full databases of astronomical information in your programming language context. Now, as computer scientists, we quite like to live in rarefied worlds where we don't have that much information around. Okay, depending on your field. And there's a parallel track here about mega data, and those guys are probably thinking all the time about major data sources. But in the programming languages world, we don't want that many. We're happy with, well, in fact, when we did F# 2.0, we were really happy that we had all those .NET libraries available. We had like 1,000 types or something, or 50 libraries that we could suddenly use to do all sorts of interesting programming. In this setting, we've now got hundreds of thousands of types and millions of objects or instances of facts or objects available to us in our programming language context. And you have to imagine yourself that you're not necessarily a computer scientist who doesn't need so much information to do the publications and work, but you're actually working as an astronomer, or you're working in one of these information-rich fields. And how easy can we make it to just get the world's data, the world's information in the programming language context? So if we go to, say, chemistry, and we look for the chemical elements, we can actually evaluate those depending on how happy the web connection is with us. It's pretty good. So we have here the chemical elements, and the key thing here is that we're not just working in a dynamic language programming environment, although I'm doing some interactive evaluation along the way. Let's yield here. That we're working in a strongly typed setting, so that as I write a query for E in each of the chemical elements, strongly typed. And very much Nikolai brought this out already in his talk, that the reason we're interested in strong typing is not just about all the software engineering properties, but in terms of the inference that's being done over the program text during what we would call design time or code editing time in Visual Studio or in F# talk. So that means we have type inference here, which means we get IntelliSense. It not only means we get IntelliSense, but it means we get these definitions coming through. We can propagate metadata information through about the data sources that you're working with. So when you come to boiling point, imagine if you had to design this library. This would take a very, very long time to design and to import that data from that external source. But what we're doing is changing programming so that you just work with these external ontologies. They're just there. They're just part of the world in which you work and program and live. Okay. So for example, let's say you need, as part of your work, information on the list of languages in the world. Okay, then you would just come to web data, and it's quite odd, there's many different times in programming that you might need the list of the languages. Then sure, you have the list of human languages, and you can just to get that and evaluate it. You have image data for those languages, you have lots of property information, and you have even a definition here for what is a human language. And once you have that set of human, interestingly for these human languages, if we take the first one, you can use head here and have a look at its properties, then the world of the semantic web has done the work for us of even relating these to particular, the key identifiers that allow us to relate these languages through to other ontologies and to other services. So we're not locked into the one view of the world here. We have the key links and the key pieces of data here to be working with other kinds of data as well. And it's also, they've done a very good job of organizing the properties and the relationships between these data. Now, something I'd like to emphasize here is that this data is incredibly interlinked. So let's take one example of that. So in terms of so let's take the chemistry, take the chemical elements, and we'll take the head one. And then we talk about the discoverer here. Let's run through this. And we discover, there could be multiple discoverers. So we get the first discoverer, and we get, say, the discovering country here. And we get the first element, and we get, now it's a country. So we've gone from chemistry through to information about countries. We're suddenly in a completely different part of the web, the semantic web of information. And this goes against many of our instincts as library designers. If you started to design a library for chemical elements, you wouldn't think that you would end up designing a library, getting to links through to countries and currencies and forms of government and all the other relations that the countries have always had. But if we take a semantic web view of information and then the right programming language view about getting that information into the programming language context, and we make sure we have the right elements in our language, like a good dot notation and IntelliSense and everything, then it's clear that this is actually very, very useful to have these relations. If you are building a historical chemistry application to display the people and the countries who displayed for school students, for example, then yeah, I mean, maybe the calling code isn't actually the interesting thing about the country, but then there will be other forms that it's quite reasonable if it's a historical application to say what was the form of government at the time the chemical element was discovered and what sort of scientific community was there and so on. You might be interested in getting that kind of information across to your students. So the information is useful in application development and in information-rich application development, and the relations are useful, and the interlinking of the semantic web is unbelievable. Now, the key thing from the programming language perspective here is that we are we're using an open architecture, and this particular ontology or this particular piece of web-based data is just one example of what you can project into the programming language context. We're not tying F# to any particular kind of data, not even to any particular format for data. The world of big data on the web and in enterprise is like the Wild West, okay? Every day someone's coming up with a new format, people are rolling into town and setting up camp and running other people out of town, and everything's changing every single week almost in different kind of standards and initiatives, and Google's got a lot of things going on, Microsoft has a lot of things going on. And so we have to have architectures in our programming languages that are going to last the next 10 or 20 years to allow us to live in a world where where the information base is changing. So we have an open architecture where we can project in web data and many different kinds of data through adapter components. It's in many ways not a surprising architecture. What's the most surprising thing is just how amazingly useful this architecture is. Just to give you a feeling for the kind of .NET code you would have to write to get strongly typed views of this particular ontology. The underlying API for this ontology is freebase.com with some JSON API where you have to start giving HTTP strings and the data eventually comes back. You could type this string into your browser and you could get the data that we're seeing. It just would be incredibly clunky to do it, and then you have to parse it into these strongly typed record fields, and you end up writing code like this. I mean, if you draw the spectrum of programmer skills, right, this is way down at the right-hand end, right? Programmers have to be very good to put together these elements to even get any data into a strongly typed programming language. And this is a pretty full-featured programming language that by today's standards, it's actually very good, but for doing this kind of work. But we have to make this vastly simpler. And what we're doing when all you have to do is go webdata.chemistry.chemical-elements to access that data source. And we've pulled that all the way back to the other end of the programming language spectrum and made it, I think, literally 1,000 times easier to be able to work with this particular data source. And there's a particularly interesting application because the size of this application is thousands and thousands of types of information in that web ontology, and we need an architecture which will scale to that kind of type, that kind of data. So the magic we're doing is just changing our notion of what is compiler architecture. That we're going to use a plug-in notion and an extension. So there's many different ways you can rip apart programming language implementations and plug various things in. And what I think is special about this is that we found one particular point, which is just to adapt name resolution and the notion of library importing. What is a library? We're saying a library is not just a library as in a DLL or some physical bits on disk. A library is a logical component which can project in arbitrary information sources, which for the purposes of the schemas of these external information sources are sufficiently constant that for most purposes, that we can accept there's a trade-off here. We're obviously losing some static typing in a sense, losing some strong typing guarantees because the schemas of these things can change. The service can disappear, right? And suddenly your program doesn't really type check anymore. It doesn't, or at least doesn't run correctly. So we're trading off a little bit in terms of the programmer has to manage that relationship with the schema change in the database. And in turn, we're exploding the amount of information that is available to the programmer. So these components are relatively small. You reference them as you would any other component, except they're just projecting a logical space of types and a potentially infinite space of types. You could think of it as being a lazily explored space of types, if you like. They're all nominal types. It's a strong emphasis on nominal types rather than using structural types. But that works fine. I mean, part of the lesson of this, I think, is that nominal types are really a good way for representing real-world entities, and they're at least, well, I think that's one of the research questions is, okay, if we change our notion of what the type system is for, and it's for representing this kind of stuff, then what relationships do we want between types? There's going to be a lot of familiarity in that. Suddenly the role of things like security types becomes vastly more important. So the role of things like units of measure becomes vastly more important because suddenly all these data sources really do come attached with units of measure in their descriptions. And so I think this changes how we think about type systems and programming languages. There's a question of granularity. What's the right lens? The type system, suddenly you realize for some applications you really want just an arbitrary notion of an ontology object, a triple or something. For some applications, you want much more fine-grained notions of typing, and actually probably want multiple views of the same data source. And this kind of setting can cope with that. You can have the programmer select between the various possible views of the data source. Do you look at an Excel table as individual cells? Do you look at it as a rows by named column? You've got multiple views over the same information sources. Okay, so just to say these components are very small. So these two instances of type providers are in the order of maybe they're 1,000 lines of code or between 100 or 1,000 lines of code. They're not big components as adapter. So a type provider is a design time component that provides a computed space of types and methods. You can think of it just as a compiler and IDE extension. That's fine if you want to think of it in pragmatic terms. And it's adapter between data services and .NET languages. The API is incredibly small. I love this API because this is the static semantics here of it says give us a sufficiently rich type description in the middle of given a name. You can ignore this second one. We've actually removed that. And this is the runtime semantics. This is the static semantics for the world. All the world's information sources go bang through this particular description. And then this is the runtime semantics, so how to access all those information sources gets dropped in through here to say, give us enough meta information. And then we reverse compile that meta information down into code in the F#, when we're actually running F# code. So they're not big to implement, and they map information sources into the .NET type system. They do require a bit of skill to implement a type provider because you have to be sufficiently good at thinking about object relational mappings or schemas and type-based programming and so on, but we wouldn't expect everybody just to be writing a type provider, but it would be not too hard to do them. Okay, so people today mediate between their program and all these data sources by doing oodles of code generation. Microsoft just loves code generation tools. If you go to Visual Studio, half of Visual Studio, actually really it's interesting to look at Visual Studio and those kind of IDE environments. Really, half of those environments are all about mediating with external source of information. You've got your Server Explorer on your right and your SharePoint server and then your data schema designer and all sorts of other bits and pieces just to kind of work with those external data sources. And much of this actually, one reason why we're doing this in F# is because F# actually has a trouble inside Microsoft in being able to play catch up with all that fancy tooling, which is actually incredibly expensive to build, all those click, click, click things. And we have to, by putting in a very general mechanism and an adapter architecture, then we can open that up to the community to build these adapter components, and we don't have to play catch up with all those designer components. And code generation has all sorts of problems in practice. It's just like you see you just see the mess that programmers get into when they take their generated code and they start editing it and adapting it and checking it in. And it's just unbelievable what a mess modern software engineering becomes because of code generation. So I'll just show one more example of this, and then I'll wrap up and hand over to Manuel. This example is the Microsoft Windows Azure Marketplace data market. It's as I say, it's a one-stop shop for data, and you can. It's meant to be a place where you can host data on the web, but they also host. It's about professionalization of the hosting of data. So when you sign up for, you sign in with to Facebook or whatever, or your live ID up the top, and you acquire a data set. You get the rights to access a data set. You get a contract that the schema of that data set won't change for a year, and it will be available for a year. Okay, and then maybe you get the first 50,000 queries a month free, and then you start to pay money after that, or something. There's some kind of payment arrangement, and so that's all about professionalization. There's a way to pay for your money, pay for your data. There's a way to it's just the usual marketplace kind of thing. So in this sample, we take a small type provider for the data market. And once you have the type provider, the idea with the type provider is you're always designing a data space of some kind. And in this data space, the idea is that you walk to Windows Azure and you say, what does Windows Azure have? It has a marketplace, among other things. What's in the marketplace? You go over and you see there's various shops, and one of them is a data market here. They say, well, what are they selling at the data market? And not too surprisingly, on the tables, they have data sets. Okay, and so what data sets do they have? Okay, we're not just dealing with one data source now. We're dealing with many different data sources, and things like the data market start to aggregate many different kinds of data as well. There's this game going on that everybody who publishes data is also becoming a way of aggregating arbitrary feeds of data. So if you look at SharePoint, suddenly you can aggregate all sorts of things in through SharePoint. If you look at Google data sources, I think you can do the same, or Freebase starts to aggregate all the world's information sort of through that. So there's many different people trying, as I said, it's a Wild West in a way. But this, as you can see, we start to aggregate all sorts of professional data sets into the data market. So if we go, for instance, to statistics here, then we get some of the big, major, free and open data sets. We have crime statistics, or you get greenhouse gas emissions, or this FAO, food and agriculture data. And I happened to be in the airport, and I met someone who works for the FAO as a veterinary epidemiologist. And I said, oh, really, you work for the FAO, right? And so have a look at this. And I typed in this, and I pressed dot. And she just could not believe that the data that she worked with every single day was available so easily in this, and then we did some charting with it and so on, that she so easily in a programming language context. Suddenly your programming language becomes relevant to all sorts of other people's work that it was never particularly relevant to before, or it's a stretch of the imagination. You'd always be predicated, oh, if only we had the FAO data, then the programming language would be useful for my work. So to take a fairly negative one, we'll actually look at the crime data in the United States. This happened to be the first on the list, so it's what I did. You have to do a little bit more work in these examples, but we can start to just query the crime data for 2006, 2008. We can start to query it here. So for instance, we can take the crime data where the population is not zero, the violent crime is above a certain level, and we do city and violent crime. You'll notice that these are all cities in Alaska, because the default for this data provider is to provide the first 100 elements of this data set, and they come out as all being in Alaska by default, which is not good. So we actually want to be able to have link queries that we send to the database that filter on the database and then project out a smaller part of that. And that doesn't happen automatically above this. If you use this new feature of F#, which is putting link queries into F#, we have a query sublanguage where for each of the elements in the crime data, we can say we want New York in 2007. And then once we have that, this is what we're allowed to run on the server. We can do some post-filtering on the client, which is this part here, some additional where clauses and selections here. So if we run that, then we'll be getting the top crime, the cities with the highest crime statistics in New York in 2007. Okay. So just to say, this has many applications. Let me pull this up. Applications to information sources on the local machine is a surprising one. That this is on every single PC or Mac or anything. There's a huge amount of schematized information, which is according to management standards for when these things are managed by professional people on networks. And if you want to know, for instance, what are the well, let's take a look what you can get down here. If you want to know what your devices are, or your installed elements of software, or all the batteries on your PC, or you want to say, imagine you're a system administrator and you want to write a script which is going to run on your machine. We're going to interrogate every machine on your network to find a particular battery or a particular device driver with a particular ID code, production ID code, because you know those are faulty, okay, and you want to take those out before they burn your laptops or something. Then you can use this kind of programming to be just immediately finding those elements that you want in your enterprise information-rich context, and then be writing your script and off you go. And this is so much easier than other ways of interrogating and accessing information in that enterprise context. Okay, so I think I will wind up. So the aim is we start to do some other things. Microsoft are involved in a standard called OData. It's a little bit like GData or other things. It's like a weak form of relational data for the web. Streaming data, it's good, and and you can, with the next version of F#, you'll just be able to give a URL here, which is the service you're connecting to, and start doing strongly typed programming directly against the service. Similarly, with a SQL connection, all you have to do is give a connection string to the database, and you'll be able to start using the database tables immediately. And interestingly, in Microsoft, it turns out that like 5% of the world's programmers now, or 5 to 10%, I mean, it depends on how you measure it, are actually SharePoint programmers. The SharePoint is one of the fastest growing products at Microsoft, and it's being very successful inside enterprises. And so the ability just to point to a SharePoint site and get all those lists of information that are being shared collaboratively between your teams is a very interesting application. And I think that leads, so I'll skip the query part because you've seen those. That leads to other interesting, many interesting data sources we can project in. We have web data, data markets, management information, spreadsheets, web services. This CRM data is sort of enterprise resource planning data. An interesting area we haven't explored yet, but is a modern theme, is sort of social data. What happens when you work with maybe Facebook, or maybe more open versions of social data, and more pragmatic ones like SQL and XML. So that's the vision, is to be working with these data sources strongly typed without explicit code gen in an extensible and open way. So our mantra is the world is information rich, and our languages need to be information rich too. And so the future of what we're doing with F# is just to make sure to not throw the baby out with the bathwater and have to move to a dynamically typed language or dynamically typed programming in order to solve this problem, to allow us to keep strong typing and just sort of break down the walls between the programming language and these external data sources. Okay, so there's some books on F#, and I think that's what I wanted to say. And do we have questions? And then we'll soon hand over to Manuel. Do you want to come and set up?